This video is about critical path analysis. Here we've got a network showing activities involved in a process. So we've got activity A that takes 10 days. Activity B takes 4 days. Activity D takes 4 days. Now activity H and activity I can't take place until activity D and A have been finished. This dummy activity shows that H and I require D and A to be completed. This topic is called critical path analysis because some of these activities are critical to the whole process. Any delays in some of these activities will cause the whole project to be delayed. It's important to identify which these activities are because these are the activities that need priority to make sure there's no delays. Now part A asks us to calculate the early time and the late time for each event, showing them on the diagram in the answer book. And we need to determine the critical activities and the total float. So we'll go on to the next slide to see what sort of diagram you get given in the exam. So here we've got the same network, the same activities A, C, dummy and so on, but we've got these two boxes at the end of each activity, and in these boxes we're going to need to put the early time and the late time. This is what we do. So let's consider activity A. What's the earliest time we can complete activity A? Well, that's clearly after 10 days. What's the earliest time we can complete activity B? That's after 4 days. Now if we consider this node here, it requires B and D to be completed, and it requires A to be completed. So what's the earliest time we can arrive at this event here? Obviously this is going to take 8 days, but this takes 10 days. So the earliest time we can arrive here is at 10 days. What's the earliest time we could arrive at this point here? Well, 10 days there, 5 days there, that's obviously 15 days. What's the earliest time we can get here? Well, if we've got activity B and E, that's going to take 18 days. But if we're going to B and then D and then I, that's 10 days. Activity I takes 9 days, so the earliest time we can arrive here is after 19 days. What about at this point here? 18 days to get there, 20 days if we require activity H to be completed. So the earliest time we can have all the activities completed up to this point is 20 days. Now let's consider here we need activity J to be completed, we need activity K to be completed. So if we're requiring J to be completed, that's 22 days, but if you require K to be completed, that's 26 days. So the earliest time we can arrive here is 26 days. At this point here, we've got to choose between 30 days and 34 days. So the earliest time we can get to this point is 34 days. Before that, activity M won't be completed. So at this juncture, we've got to wait for 34 days. And then finally, the very end point, we've got a choice between 39 and 32. So the earliest time we can get to this point is 39 days. You might say, well, hang on, 32 days, 19 and 13, but after 32 days, we still haven't got to this point. So the earliest time we can get there is 39 days. So this is called a forward pass. I forgot to put the naught in at the start, which you always put in. Let's make that a proper 0, that's better. So that's called a forward pass. We've started at the beginning and we've worked through to the end. We're now going to do a backward pass and work backwards. So we've got 39 days is the total length. So now we're looking at the latest time we can start these activities. So the latest time we can start this is at 34 days. 39 minus 5, 34. The latest time we must start that is 34 days. So the latest time we can start activity 8 is after 26 days. What about this point here, the start of activity K and L? What's the latest time we can start that? The latest time we can start that, seeing as this point is 26 days and this takes 7 days, has got to be 19 days. Don't think it's 26. It's not 39 minus 13. The latest time we can start this is after 19 days. If we start activity K after 19 days, it's going to delay things. So the latest start time at this point is 19 days. So far you'd be thinking, well, hang on, these numbers are all the same. But think of this one. What's the latest time we can start here? Well, we don't have to start activity J until 24 days. Because J takes 2 days, we've got to start this by 26. So this point can be 24. So if we don't start activity J till 24 days, we're not going to delay things. What about this point here? Well, 24 minus 10 is 14. 19 minus 9 is 10. If we start this after 10 days, we're not going to get to here at 19, so this has to be 10. So 24 minus 10 is 14. 19 minus 9 is 10. It's the smallest of those numbers that we need to put in there. What about this, the start of F and G? Well, 34 minus 15 is 19. 24 minus 3 is 21. So we have to take the smallest of those values, 19. If we start activity F after 19 days, we won't get to there for 34 days. So the latest start time here is 19. So 1 there. There it is. So what about the start here? 10 minus 4 is 6. 19 minus 14 is 5. The smallest number there is 5. So we can't. So the latest start time at that point is 5. If we start activity E after 5 days, we won't get to there in time. This is 10, so that means we're comparing 10 with 14. 19 minus 5 is 14. So the smallest of those is 10 days. And then obviously 0 back at the beginning. So now we need to consider the critical path. What are the events which must be done on time? And we can do this by looking at the numbers which have the same top and bottom numbers. There to there to there. Oh, it's not there. There and up and like that. Any delay in these activities is going to cause a delay in the whole project, and we won't get it done in 39 days. So the critical activities are A, I, K, M and N. This activity here is a dummy activity, so you don't need to write that in. And the total length of the critical path is 39. And it's 39 days. Now the float on the activities is like the slack time, and activity F, the way to do this is to take the 34 there, the 15 there, subtract those, that's 19, and then take away that 15, and that's 4. So that's 4 days. What's the float on activity G? Take the 24 there, the 15 there, 24 minus 15 is 9, take away that 3, so that's 6 days. Now we're going to draw a Gantt chart, which is like a project management chart, to show how the project can take place. Now, it's not possible for me to draw these with a ruler, but you really must draw these with a ruler and as accurately as possible. The first thing is to draw the critical path. A was 10 days, so I draw a box from 0 up to 10 and write A inside. I goes from 10 days to 19 days, so that's like this. But your diagram should be better than this. You should draw it as neatly as possible. K, if you refer back to the diagram on the previous page, K goes from 19 days to 26 days. So that's like that. M was the next critical activity from 26 to 34. And then N goes from 34 to 39. So that's like that. So that critical path is the bit that we always start off with. We always start off with that. Now activity B goes from 0 to 4 days. So I'm going to draw that like this. There's activity B. But there is there's an extra day. There's a float on B of 1 day. So that gets drawn like that. Activity C starts after 10 days and finishes after 15 days. So I'm drawing, so 10 to 15, seems to be an ambulance going by. So it's 10 to 15 days, and there's an extra 4 days slack from 15 to 19, which is like this. So I draw that in like that. So notice that activity C, the early years start time is 10 days. The length of the activity is 5. My diagram's not terribly good there. Should be at that should be at 15. And the latest start time, sorry, the latest finish time is after 19 days. So that goes up to 19. What about activity D? Activity D, the earliest start time for activity D is after 4 days. The length of activity D is 4, so that goes up to 8. And the latest finish time is 10. So D needs to go up to 10. I'm going to keep emphasising you must draw this with a ruler and you must be accurate. This is activity D. Activity E also starts after 4 days. The length of the activity is 14. So 4 plus 14 is 18. But the latest finish time is 19. So there's an extra bit there. Shows that. And E is like this. F starts at 15, the length is 15, and the latest finish time is 34. And then G, H, J and L all done in a similar way. So it ends up looking a bit like this, but yours of course will be done perfectly with a ruler and it will be very accurate. I've gone over a little bit at various points, which is annoying me. That should be at 39, that should be at 39 and so on. Now the minimum number of workers we need to find for part E, and what we need to do is to find are there any crucial points. Bearing in mind that these activities can sort of slide along, so C doesn't have to start at 10 and end at 15, it could end at 19 and start at 14. But at 14 and a half days, obviously activity I has to take place. C has to take place after 14 and a half days. Whether C is there or whether it's shifted along a lot. E has to be taking place at that point. F isn't, that isn't, but H is, and even if H slides along, after 14 and a half days, H is still has to be able to take place. So, however we slide things along, H, E, C and I all have to be taking place after 14 and a half days. So that's what we need to write as our answer to part E. I'll do that on the next slide. So there would be a good answer for that. At time 14 and a half, or after 14 and a half days, there are 4 tasks, i.e. H and C. Tasks, activities, either word is okay. There's 4 tasks that must be happening. So therefore we need 4 workers. And that's it.